Okay, so now we're going to talk about 2.2. Going into the notes here for 2.2, it talks about the limit of a function. This is just kind of a generic, nice, easy way to deal with it. It says, suppose the function is defined for all x near a, except possibly at a. So that would mean like you could have a hole in the graph. Like, do you see this right here, how we have a hole in the graph? So when x is 2, there's a hole in the graph here. There's a dot up here at 5. But when x gets near 2, so when I'm like 1.9, 2.1, as I get near the x value of 2, the y values are getting near 3, but it doesn't equal it. I wonder what that is. Oh, yeah, look at that. So, oh, look at that. That's kind of fun. So, same thing here. As the x values get near 3, the y values get close to 4, but when x is 3, it doesn't equal 4. So a lot of this, idea of a limit is what's happened is that we get near the number. But it doesn't matter whether we actually equal, the function's value is the same. It doesn't have to happen that way. So on that first question I saw, it said, when a limit exists, is it always equal to f of a? And the answer would be false. The limit, if it exists, depends on the values near the a, but it doesn't depend on the value of the function at a. So remember, f of a represents the y value when x equals a. That's how I would read that. All right. Next question. All right, this is notational. This means the limit as the x value approaches the value b from the right of r of x approaches L. So as x approaches b from the right, the value of the function r of x approaches L. That's how we would read it. If it did not have a symbol at all, if it was just b, if it didn't have a plus or minus there, you would say from either side. If it has a minus sign, you would say from the left. All right. So this is telling me that if the function, as I approach a from the left, the function approaches L. As I approach a from the right, the function approaches m. It says where L and m are finite real numbers. Then what must be true about L and m in order for the limit to exist? What must be true is that the left-handed limit and the right-handed limit must be equal. So a nice little picture here. Well, I don't know if it's going to be a nice little picture here. But if I were to, if I were just to kind of, give you a picture of what was going on here, let's move that out of the way, then this would be kind of that picture. It's going to be a really bad picture, apparently. Can't draw straight lines today. But the first one says the limit as x approaches a from the left. So if this is a, and that's on the x-axis, this is on the y-axis. As I'm approaching a from the left, that would look like this. That's saying that the function's value, whatever it may be, is approaching L. Then it's saying as I'm approaching a from the right, the function's value must be approaching the same thing. It has to be approaching m. So what this tells me is that L and m must be equal. So as the graph of f approaches this way and this way, so this is my f of x, guys, it's horrible. But as I get closer and closer to a from the left, as I get closer and closer to a from the right, these values need to be going towards each other. I don't care if there's a hole there or not. So the limit as x approaches a from the left of the function approaches the number L. The limit as x approaches a from the right, the limit, sorry, I was going to say that right. As x approaches a from the right, the limit of the function approaches m. But in order for this to be the true, in order for the limit to exist, In order for the limit to exist, the left and the right hand limits must be the same. Meaning as you approach from either direction, you end up at the same value. It would be bad if I was, if it hit here, then here, right? So like if I did another graph, if this was A, and this was L, and this was M, then that wouldn't work out. This limit does not exist. There's a gap there. So here, the limit as x approaches a of the function does not exist because L does not equal M. Even if I filled in one of these dots, that doesn't matter. There is a gap there. Apparently my phone is telling me I have somewhere to be shortly. All right. So let's look at the next one. I guess I should check that. All right, so now we've got a graph. I'm going to blow this graph up. Whoa. I'm going to kind of smush it. Oops, wrong one. All right, so here's going to be just reading how to read the graph of this function. So they're calling the function h of x, and we are wanting to figure out the following. We want to know h of 4 and the limit, all these limits. All right, so the first thing, h of 4. h of 4 is where this dot is right here. So this is h of 4. So h of 4 equals 8. Because that means the y value when x is 4. H of 7, let me go ahead and do this one. H of 7, well, h of 7 does not exist. There's a hole there. So DNE does not exist. All right, now we have some following limits. So it wants the limit as x approaches 4. Well, that would indicate from both directions. So as I approach 4 from this direction, the graph is approaching the y value of 6, right? As I approach 4 from this direction, I guess I got to use a different color. As I approach 4 from this direction, the y values are still approaching 6, right? So all throughout here, those y values are approaching 6. So the limit as h approaches 4 will be 6. Same game with 7. Here's 7. And if you come back and look, as you approach from either direction here, both of these, as you're coming in close here, both of those approach 1. And then the limit of 8 has got, it actually equals it there. But as I'm approaching here, those y values will be approaching 2. So it doesn't matter whether it's defined or not. It just matters whether it's meeting up on both sides as you approach it. That's a good way to think about it. All right, so let's see. What did we say h of 4 equaled 8? Fantastic. And then that was 6. Well done. H of 7 is undefined. But the limit was equal to 1 because it approached 1 on either side. And then H was just one of those, everything worked out fine and it approached 2. All right. Here's another one. Same kind of game. So you should be able to complete that one now. Number 6, again, very similar. I want to see if there's anything exciting on these. Not really. So like if you look here, f of 2 would be 5, but the limit is actually 4. Yeah, so these aren't going to be bad at all. But it takes a little bit of time to do that graph reading. Here, it says make a table of values. So we have this function t minus 100 over the square root of t minus 10. And so again, this is a lot like what we did a second ago with the average velocity thingy. So this problem, t minus 100, if I can remember it. So x minus 100 divided by, and then the square, oh, let me close it, parenthesis, square root of x. Now, if you're in the old system, make sure you close that. If you're in the new system, make sure to arrow out. Okay, what's going to be a little bit easier about this one, oops, is that what does it want? Round to 4 decimal places. So to get it exactly, I'm going to come back out here and do my vars, y vars, and I think plug in 99.9. And so if I round to 4 places, this 9 rounds it up from 49, from that 9 to a 0 to a 5. So it'd be 19.9950. So 19.9950. 19.9950. Okay. Now I'm going to do the same thing again. This time it wants me to have an extra 9 there. So again, this would be 19.9995. 19.9995. And then lastly, there's another 9 in there. So that 5 is going to round it all the way up. It's going to be 20.00000. So let me throw this in here. So 20.0000. Because again, this 5 rounds that and it keeps rounding all the way up. Then it wants me to go the other way. And then it's going to want to make a conjecture, and it's going to be 20. But that's how you can use your table to do this type of problem. Let me snag this in here. All right. Let's see. I think the next ones are going to be... let's see. Yes, I want to leave the question. All right, so this would just be graphing. There's some parts remaining. Just make sure to use parentheses on the top and bottom. But we'll do some more of these on the next video. All right, so there's a couple of problems where they want you to estimate a limit graphically and numerically. So if you're graphing this in your calculator, just make sure... I didn't put an extra set down here, but if you're in the old version, just make sure you do the parentheses appropriately. The best bet is to do parentheses around the top, and then the denominator is good because it's just one piece, but that wouldn't hurt. Or if you have the new system, you can do the, alpha y equals enter to get the fraction bar. And so here was my regular graph, and so then I did zoom to and enter to zoom in. And I noticed that it looks like as I'm approaching 1 from either direction, it looks like this graph is approaching the number 2. So that's what I would put for this one. Then on evaluate for values near 1 to support my answer. I don't know if they're going to want you to type it in. I guess I can actually see here. So this is similar to the one we just did. What's the only difference? It's 4. So I wonder if it's still... Yeah, still looks the same. And so it appears to be 2. Alright, and so now it's going to want you to do these. So notice how you've got these numbers here. So what you could do, I was going to go ahead and make that table like this. And in fact, yeah, it's not quite there. So what you could do, and again, mine's a little different. What I should have done is gone to my table set and gone ahead and done ask. And then I could have typed in 0.9, oops, 0.9, 0.99. Oh, round to 6 decimal places. Blah. That's the only limitation with the table. So, what you would do is you would do your vars, y vars, and then do your 0.9. And then do it again with your .99. And so on. And eventually you're just going to have to take those out of there. Eventually it's just going to round to 2, even if you go out to 6 places. So this would be that. So it would be 1.993342, and here it'd be 1.999932. But you would just go on and finish it that way. All right. This one is finding the limits from a graph. And so the first ones I want to take care of are the ones that aren't the limits at all. That would be g of -1, g of 1, and g of 5. So g of -1, I wish I had different color, more colors. If I look straight across here, that would be at 3. So g of -1 is 3. G of 1 is right here. So that would be 2, because that's where the solid dot is. And then g of 5, so here's 5, so I'd come up here. So g of 5 appears to be 5. I have to kind of assume it keeps going like that. All right. Now, let's look at these limits. So, as I approach -1 from the left, that would be approaching this way. And then as I approach -1 from the right, that would be this way. But notice both of those go to the number 2. Now, but as I approach -1, it's also going to actually equal the number 2. Just because there's a hole there, I'm not worried about equaling. I'm not worried about, what does g of -1 equal? I'm worried about what happens as I get close. And as I get close on the left and the right of that number, they both approach 2. Now, this limit, on the other hand, is x approaches 1. That would mean from this direction and this direction. That does not exist. There's a big gap. If you notice, the limit as x approaches 1 from the left of my function is 4, and then the limit as x approaches 1 from the right of my function is equal to 5. So this would be as I approach from the left, that function is approaching 4, and then as I approach from this direction, the function value is approaching 5. So, no good. And so because of that, this limit does not exist. So if you look at the orange and the pink together, it does not exist. All right, the next one is the limit as x approaches 3. So 1, 2, 3. So as I come up here, I'm just going to use this color. Everything's nice. And so as I come close to 3 on this side, the function's graph gets close to 4. So this equals 4. And then the last one has me coming -5 from the +5 from the left, which is this way. And as I'm approaching this way, if I trace it back here, it equals 5 as well. But I don't know what to say coming both directions. And so that's how I would look at that. Let's see, the next one. Yeah, I'm going to wait on this one. All right.